In this video, I'll consider one numerical on node analysis. Find the voltage Vx for the circuit shown below using node analysis. This is the given circuit. We need to find voltage Vx, that is nothing but voltage across 7 ohm resistor. So now we need to calculate Vx, that is voltage across 7 ohm resistor, that is Vx. Let me assume this is node 1 and this is node 2. Let me assume voltage at node 1 is V1 and voltage at node 2 is V2. So in node analysis, first we have to mark all branch currents. Here there is a current source, we no need to mark. Let me assume current through this branch is I1, current through this branch is I2. Here there is a current source, no need to mark it, and current through this branch is I3. So now let's apply KCL to node V1 and V2. Now let me apply KCL to node V1, that is apply KCL to node V1. So we know that KCL is nothing but, it says incoming current is equal to outgoing current. So at this node I1 is outgoing, I2 is outgoing, and as well 4 amp is outgoing. Incoming current is 0. So I can write 0 is equal to I1 plus I2 plus 4, or I can write 0 equal to I1 is nothing but V1. This is a reference node whose voltage is 0. Its voltage is 0. So I can write I1 is nothing but V1 divided by 7, that is V1 by 7 plus I2. I2 is nothing but V1 minus V2 divided by 2. V1 minus V2 divided by 2 plus 4. I'll take 4 on left hand side. I can write minus 4 is equal to, we have V1 by 7 plus V1 by 2 minus V2 by 2, or I can write minus 4 is equal to V1, here we have 1 over 7 plus 1 over 2 minus 1 by 2, that is 0.5 V2, or I can write minus 4 is equal to 1 by 7 plus 1 by 2, so it gives 0.643 V1 minus 0.5 V2. Let me call it as equation 1. Now similarly apply KCL to node V2, that is can write apply KCL to node V2. So here I2 is incoming, I2 amp is incoming, I3 is outgoing, that is I2 plus 2 is equal to, we have I3. So I2 is nothing but V1 minus V2 divided by 2, V1 minus V2 divided by 2 plus 2 is equal to I3. So I3 is nothing but V1 V2 minus 50 divided by 5. So I3 is nothing but V2 minus 50 divided by register. So in this branch there is a register value 5. So it will be 5. Simplify this further. I can write V1 by 2 minus V2 by 2 plus 2 is equal to V2 by 5 minus 50 by 5. Let me simplify, or I can write it as 0.5 V1 minus, here we have 0.5 V2. I'll take this V2 on left hand side. It will be minus 1 over 5 is 0.2 V2. I'll take this 2 on other side. It will be minus 50 by 5. Minus 50 by 5 is minus 10. I'll take this on other side. It will be minus 2. Or I can write 0.5 V1 minus, so here 0.5 V2, 0.2, that is 0.7 V2 is equal to minus 12. Let me call it as equation 2. Now we need to solve equation 1 and 2 to calculate V1 and V2. That is solving equation 1 and 2, we get So now go to the mode, choose equation mode, that is fifth option. Here we have two unknowns, choose option 1. Now feed the values of first equation. So first A is with respect to coefficient of V1, that is 0.643 is equal to the coefficient of V2 is nothing but minus 0.5, that is minus 0.5 plus equal, then C is with respect to this value, that is minus 4, press equal. Now similarly choose the second equation. So in second equation V1 is 0.5, 0.5 equal to coefficient of V2 is minus 0.7, minus 0.7, and this value is minus 12, minus 12. So it gives x is nothing but coefficient of V1. So x is nothing but V1, that is 15.99, means 16, and V2 is 28.56. Right? V1 is equal to 16 volts, V2 is 28.56 volts. So therefore here we can observe that V1 Vx is nothing but V1. So therefore Vx is equal to V1 is equal to 16 volts. This is the required result. Thank you for watching.